Okay, everyone, so welcome back. This time we have another group problem. So grab a friend, grab a roommate, grab your rubber duck, grab your calculator. Goodness, grab your calculator. And let's see if we can solve this. So, what do we have here? Well, we have the 800 kilogram roller coaster, and that's a roller coaster's car, and it's released from rest at point A. And we want to find the minimum height h, so the car travels around that inside loop at B without leaving the track. That's the big important thing. We don't want it to leave the track. And we also want to find the velocity of the car at C. Now, with all of that, go forth and try to solve it. Remember, conservation of energy is going to be your best friend here. And do you see any springs? You don't. So all you're going to have is kinetic energy and the gravitational potential energy. The only other thing you have to think about is what is going to be my datum. I would probably choose point C, but let's see what their plan is for you. Doesn't actually say where to take it, but I would probably choose point C. Now, with that in mind, go forth and try this, and then come back and we'll do it together if you have any trouble. So 3, 2, 1, and let's start. Now they're choosing their datum at point A. Why would they do that? They always do things differently than I. But who cares? They can do what they want. I'll do what I want. And in the end, you would still get the same answer. So if we place the datum at point A, well, then at point A, we have absolutely no gravitational potential energy. It's 0 at that point because we're at our datum. But we have no kinetic energy. Why do we have no kinetic energy? Because there's no velocity at point A. But then we're going to begin going down the track, and we're going to go up and around that curve until we reach point B. Now here's the issue. I have 2 unknowns here. I can't solve yet. So how are we going to solve? What we need to realize is that at that point B, the normal force on my wheels must be equal to 0. Okay? It can't be less than 0. It can be negative to keep it balanced. So it has to be equal to 0, like gravity, the weight, plus my normal force, my centripetal force must be equal to one another. If they're not, they come off the track and people get hurt. So let's look at this. I know what gravity is. I know what the mass is. I know what gravity is. That's pretty easy. And the mass doesn't change. It's on both sides. I actually don't even need the mass for this. And I know what my centripetal acceleration is. It's v squared over rho. And luckily they gave us the radius. And so from this, I should be able to solve. And I get that it has to go at a velocity of 8.578 meters per second. 8.578 meters per second. Now, in real life, no, I would never, ever, ever make something just high enough to make it work. That's dangerous. I always want factor of safety, but here we're not caring about factor of safety. We're just going to plug it straight in. So if we do that, we get that our height is going to be 23.75 meters. 23.75 meters. Wonderful. It works great. That's amazing. I'm super happy about it. Now, if you had done what I said and made your datum at point C, you would have just found that you had potential energy at both places. And it would have just been the difference. You would have subtracted it and gotten the exact same thing. So nothing would actually have changed in the end. You would just have to probably write a little bit more. So don't always take your professor's advice at face value. Sometimes you make mistakes. Okay, so this is the perfect height to make it through that loop. Once again, in real life, you would have to make it taller to be safe. Because efficiency, everybody, efficiency. Now, once it's traveled all the way down to point C, we want to figure out how fast it's going to be going. So we can once again just use our conservation of energy equations. So we look at it, we take all of our potential energy at the beginning, which is 0. It has no gravitational potential energy, and it has no kinetic energy, and we say, well, that's going to be equal to the end. Now you're like, well, then is it going to be moving at all at point C? If it's kinetic, if it's zero, energy is going to be 0? Yes, because we are gaining that negative gravitational potential energy, which is saying simply that energy that was going to be coming from gravity is going into the system and going to something else. And it's going into kinetic energy. But overall, this will still add up to 0. And so if I then solve for it, I get that the velocity has to be 21.6 meters per second. 21.6 meters per second. So that's it. We just used our conservation of energy equation twice to solve this problem. So I hope this helps you. Thank you for listening, and I'll see you all next time. Bye.